The Math and Science Activities Center page is a great website for teachers to use in order to help students understand how to measure different masses and volumes and find the densities of objects. This will help students when they're trying to understand the abstract properties of the phases of matter. The first website is on mass, and it says that mass is the amount of matter an object has. We often use a triple beam balance to measure mass. It shows how to use a triple beam balance to measure mass, and you can go over that with your students, or you can simply show them by using the website. It tells you that a block is put onto a triple beam balance. What is the mass of the object? Now, for this, the teacher would be using one computer and one projector and projecting this in front of the class to show them how to use the website. So, the teacher could show them that to read it, here we read this number first, which is 0. We read this number first, which is set on 70, and this, which looks like it's at about 9.4. So the volume of this would be 79.4 grams. If we submit, it tells us it's correct and it's within our limit of error. Next, we have a block having the same dimensions put on the scale, and it has a different mass. So now we can find this mass. 0 is the first number, then 20 and 5.4. So 25.4. We submit that, and again it's within our limit of error. Now let's say that we had submitted 25.0. It says try again, but take a look at the hint link first. And the hint link says add each of the values shown, and it helps you to be able to read them better. So problem 3 says if both objects are put on the scale at the same time, their total mass would be, so now the students need to add the 25.4 grams here to the 79.4 grams there. So 25.4 and 79.4. On the website there is a calculator for the students to use. So 25.4 plus 79.4 equals 104.8. So if we scroll down, both objects would weigh together about 104.8 on the scale. And it tells us that this is within our limit of error. So let's move on to volume. Okay, it tells us that volume is the amount of space an object occupies. The volume of an object can be calculated geometrically using mathematical equations or by measuring liquid displacement. And it gives you the formula for volume here, length by width by height. And then it also says and by using a graduated cylinder to measure liquid displacement. So first let's find this way. And it's showing a cube that's about 3 centimeters long. And as we know, volume would be length times width times height, which you can go over with your students again, and they're probably learning in their math classes. That would be 3 times 3 is 9, times 3 is 27 cubic centimeters. Again, they have the calculator if they need it. And this shows it's correct and it's within the limit of error. Then down here it says the side of the cube is approximately 3.1 centimeters. So how many inches does this convert to? We can use our calculator again and show 3.1 centimeters divided by the 2.54 centimeters per inch, and we get 1.22 inches. And we'll see if this is correct. Oh, it's within the limit of error again. So now we're going to be using a graduated cylinder and measuring liquid displacement. So as you can see, before we put the block into the water, it looks like it's at about 150 cubic centimeters or 150 milliliters. Over here, it looks like it's risen to about 78 milliliters, or 178 milliliters, excuse me. So 178 minus 150 is about 28 milliliters, or cubic centimeters. So if we submit, It's within my limit of error, so that is correct. Now it says, note that both methods give fairly accurate values for the volume of the cube. We had said 27 on one and 28 for another. Why are the volumes not exactly the same for the two methods used? What are some factors that will determine the accuracy of these measurements? You can go over these with your students and have them come up with some ideas. They can talk about one being more accurate than the other, that possibly the water displacement one would be more accurate because you're not having to take an estimate of each side and then multiplying that together. And then, as you can see here, this just gives you a little converter, so you can type in any value for length and then click on one of the other boxes. So if the length of the side is 2, the area of one surface is 4, and the volume of the cube would be 8. And that can just help them to do some of the math up above. So now we can go on to density. And I like this picture here. It can really help the students. It says, take a look at the two boxes below. Each box has the same volume. If each ball has the same mass, which box would weigh more and why? I think this is a really good visual for children to look at so that they can say, oh, the boxes are the same size. Okay, all the balls are the same size and they weigh the same amount. So which one of these boxes would be heavier? Obviously the one packed full of balls over here on the left is going to weigh more than this one over here on the right. And then it goes on to say, the box that has more balls has more mass per unit of volume. The property of matter is called density. The density of a material helps to distinguish it from other materials. Since mass is usually expressed in grams and volume in cubic centimeters, density is expressed in grams per cubic centimeter. Then it says we can calculate density using this formula. Density equals mass divided by volume. It goes on to say that in the previous lesson we calculated the mass and volume of 2 blocks. If you'd like to review these selections, click on the appropriate link shown at the left, and we do not want to do that. And then it shows the second block. Then it says, let's try to calculate the density for each of these blocks. Please enter your answer for block 1 in the space provided. So block 1, we have 79.4, and we would have to divide that by the 29.8 cubic centimeters. Again, we have our calculator. 79.4 divided by 29.8, and we get 2.66 grams per cubic centimeter. 2.66. And it says that that's within our limit of error. Alright, now for block 2, we have 25.4 divided by 29.8, and we get 0.85. So if we submit that, we are within our limit of error. What is each block made of? Okay, so the first one was 2.66. That is probably going to be aluminum. So we type here aluminum. And the second one is 0.85. If we look here, wood is exactly 0.85. And we can try submitting these. The answer is correct. And wood is correct. So now we can look at density of a liquid. You are given 2 unknown liquids. Find the density of each. And we have a 100 milliliter graduated cylinder, a triple beam balance, a calculator, and 2 unknown liquids. So to find the mass of the empty graduated cylinder, pour the first liquid into the cylinder to 50 milliliters level. Find the mass of the graduated cylinder, and then repeat the steps. Now for this, it might be useful for the teacher to actually have the cylinder in front of her, but they don't have to. So now we can go through the steps. For liquid 1, the mass of the empty graduated cylinder is 78 grams. The mass of the graduated cylinder with the liquid in it is 128 grams. So if we want to find just the mass of the liquid, we would take the 128 and subtract 78, and that answer is 50. The volume of the liquid is also 50 milliliters, so the density would be mass, which was 50 grams, divided by volume, which was 50 milliliters, so the density would be 1. And we'll see if that's correct. And it's within our limit of error. For the second one, the mass of the empty graduated cylinder is 78, and with the liquid in it, it's 117.5. So if we use our calculator, we have 117.5 minus 78, we get 39.5, and we have 50 milliliters of that, so our density is going to be 0.79. And that is the correct answer. So we have 1 and 0.79. So the first one, 1, is going to be water, and 0.79 is going to be methanol. So we have now completed all of the activities listed here to help understand about densities and masses and volumes. This should help the students to really understand the different stages of matter and how the density changes, whether it's a liquid, a volume, etc. And if you want, you can also use the density of liquid using a hydrometer, but that would probably require more technology, possibly not available in the classroom. And that was the math and science experiments, and hopefully this will have been of some help to your class.